I've been asked to make a presentation about how to get good at doing word problems. And just a little background, over 20 years teaching word problems to students at different levels, and now in the college or the university setting, trying to help people get better at word problems and doing a lot of problems myself. I have boiled it down to a few things that you need to know to be good at doing word problems. So usually it's a math class, college algebra, pre-calculus, calculus class, but these things can be used basically at any level. So without any further ado, let's take a look. Okay, let's take it from the top. The first thing that we need is to know the basic math. If you don't know the math that's used behind the problem in order to solve the problem, you cannot get anywhere. So it's important to have the math background. That should be obvious. The second step, I'm going to call it, we must take the time to read the problem. Now, notice how I'm saying that. I'm saying that take the time. It takes time, okay? If you are reading and rereading and rereading a word problem, that in my mind is a sign that you really are you're trying too fast. You're too busy. So that's why I say take the time to read the problem. That is crucial. My suggestion is if it's new assignment, read the problem from beginning to end and even read it out loud because it forces you to slow down a little bit. So take the time to read the problem. 3, identify the type. What I mean is, what's going on in the word problem? Is this a system of equation problem? Is this a law of sign problem? Is it a quadratic problem? What type of problem is it? Is it a mixture problem? So that helps you bring to the foremost of your mind the experiences that you had in solving that type of problem. Number 4, get the facts out, okay? Get the facts out of the problem. So, the numbers are in the paragraph in the problem. You have to get them out and then you own them. You could do something with them. So keep that in mind. 5, I would, if it's needed, draw a picture. Okay, I cannot tell how many times I have students tell me I'm a visual learner. There's a lot to be said for that. My point is draw a picture to help you visualize what's going on in the problem and maybe how some of the facts are related. So draw a picture. Number 6, set up an equation or formula. If it's a problem with a quadratic, solving a quadratic, you're going to get that quadratic formula out there. So, or it could be an equation, okay? An equation or formula is pretty much what you're doing in a math class, okay? So that's step number 6. Set it up. Number 7, I'm going to call this work to the answer. Work to the answer. Now that may be different for different equations or formulas. You have sort of like your own way to work equations, your own way to work a formula. What I mean by way is you're following the rules, but you may do them in a slightly different manner, okay? So that makes sense. And then last, this is good advice, check to see if answer makes sense. Check to see if your answer makes sense. If it doesn't make sense, then you need to go back and look at the problem. It's not like you're trying to check the 45th decimal place, okay? You're just seeing if your answer makes sense, because if it does, you may be right about the problem, okay? So keep these things in mind. These are distilled advice from many years, and that will help you. Of course, any advice doesn't work if you don't use it. Any recipe will not work if you don't use it. So what I'm going to do for a minute is do a couple problems. Okay, so here's a problem. I haven't worked this problem yet, but the question says the sum of two numbers is 7. If one number is subtracted from the other, their difference is -1. Find the numbers. Okay, well, this is a problem about numbers, and it's always a good idea. What's the question asking? Find the numbers, okay? I'm going to use, X and Y is good, but I'm going to use A and B. The sum of two numbers is 7. A plus B is equal to 7. Now, it says if one number is subtracted from the other. Well, we don't know, so I'm just going to say if one number is subtracted from another, so here we have B subtracted from A, their difference, that is this difference right here, is -1, okay? Now, notice we read the problem. We had to, read it through twice, basically, and we went back and reread it. Now, we're looking for what the two numbers would be. Oh, I see. This is not only a number problem, but it's a system of equations problem. I'm just going to take this equation and put it under here. Okay, now I'm going to add these two, and I have 2a is equal to 6, and so a is 3, okay? Now, if a is 3, I could put that 3 back over to here, right? Okay, now let's use a little common sense. 3 minus what's -1? It should be -4, right? Okay, well, of course, we could do the math. Let's subtract 3, okay, subtract 3. Negative b is equal to -4. So divide by -1, b is equal to 4. All right, so a is 3 and b is 4. Those are my two numbers, 3 and 4. Well, let's check that out. What's the sum? Well, the sum is 7. What's the difference? Well, 3 minus 4 is -1. So there you go. Now notice we did basically all of the steps in this problem. We may have emphasized one version versus another, or one more than the other. All right. Okay, now here's another problem. It's a little bit more involved, a little advanced math, some trigonometry here, okay? A survey needs to determine the distance between 2 points that lie in opposite banks of a river. Here we got a point right here. We have a point right here. The figure shows that 300 yards are measured along one bank. 300 yards measured along one bank. The angles from each end of this line segment to a point on the opposite bank are 62 and 53. So here we have the angle measures right here, 62 and 53. Find the distance between A and B to the nearest tenth of a yard. Tenth of a yard. Okay, well, really, what are we looking for? What are we looking for? Find the distance between A and B. This is what I'm looking for, okay? I'm going to call that little b. Well, let's see. Hey, I can just kind of redraw the triangle here. This is 62, and this is 53. We're trying to find, no, wait a minute, what are we trying to find? Find the distance between A and B. No, we didn't do that. We didn't read that right. We had to find this distance right here, and we'll call that C, okay? So we didn't read the question very carefully. All right, so remember, this is 300, okay? And then we're going to call this C. All right, well, the question is, can we find C. Well, you may remember the law of cosines, or the law of sines, goes like this. The ratio of the sides over the sine of the opposite angle are all the same. So in this case, I could do, we don't know this angle right here. Oh no. Well, we know that all the angles in the triangle equal to 180, and if we add these two together right here, we have what? 110, 115, and I subtract those and I get 65. So what I'm going to do is I'm going to say 300 over the sine of 65 degrees is equal to little c over the sine of 53. Now what do I do? What I need to do is, okay, we're going to take a calculator and we're going to take 300 times the sine of 53 and divide that by the sine of 65. Okay, when we do that, we have C is equal to 264.359. But wait a minute, the question said round to the nearest tenth of a yard. So 264.4 yards. That's what C is. Now, if we think about this, number one, did we have to know the law of sines to do that problem? Well, yeah, we would be in some serious trouble if we didn't there. Did we take time to read the problem? We read it kind of through almost twice. Did we identify the type? Well, it's a trigonometry problem. I didn't actually say that. Did we get the facts out? Yes, I redrew the triangle, and when I redrew the triangle, I realized something wasn't right. I had the wrong side I was looking for. I drew the picture. Did I set up an equation? Well, I wrote the equation so I knew what I was talking about. That's the content, okay, the formula or equation. And then I set up the information that I had. Then working to the answer wasn't hard on this problem because it's just advanced math student knows to cross multiply and you could figure out the answer. And then we want to see if that answer makes sense. Well, if this is 300, okay, this is 300. And these angles are close to equilateral. So if it was equilateral, this would be 300 as well. And 264 is pretty close. So I do think that's pretty good. The answer looks pretty good. All right. That's as opposed to redoing the problem to check the problem. All right. So remember, you can do word problems. They require a lot, and that's probably why a lot of people kind of push back on them a little bit. But a lot of problems in life that are given to you that have a math component are really word type problems. And so that is going to require us to, think through the need to take a little time. And then once we do that, we can get better at word problems and we can get good at word problems. I am not going to say you're going to enjoy them totally all at a time, but you may get something out of it when you get good at them. I hope this video helped you. I enjoyed making it for you. Best wishes.